Welcome everyone listening on YouTube. So this is our 21st live stream geometry session, and we have a lot of people here with us today. So 5 people besides me from all around the world. And today I'm going to take questions from the Czech-Polish-Slovak Math contest. So this has been going on for a really long time, even before the IMO, and it has an interesting history. So Czech and Slovakia used to be one country, Czechoslovakia, and they had their own competition. But then it broke up into 2 countries, but then they still continued the competition. And then Poland joined it later. So now it's the Czech-Polish-Slovak Math competition. And it has a really interesting structure because the 3 countries all speak a different language. So the first day, it's very similar to the IMO. Each country, they get the problems in their own language, and the contestants write up the solution in their own language. So that's the first day. But then the second day, what they do is they take, so 6 people from each country participate. And so what they do is they form 6 teams of 3 people, 1 person from each country. And so each team has 3 people from the different countries all speaking different languages. And what they do is they give them problems, and they give them 2 problems in one language, 2 in another language, and 2 in the third country's language. And you have to write up the solution in a different language than the problem was stated in. So the 3 people from the different countries have to, it's a challenge, they have to try to talk to each other in their different languages. So with that, I'm going to jump into the problems. Let me share my screen. See if I can find it. Hold on, just give me a second. All right, can you all see my screen? Thanks for joining, Rudra Narayanan. They all speak the same language, the language of math, yes. So Rudra, where are you from? All right, so, all right, thanks for joining us. So I will start the first problem. So we have a triangle ABC with AEB less than AC. We draw the tangent to its circumcircle at A. Whoops. Let's draw the circumcircle, then the tangent. And we want it to intersect line BC at D. C. All right. Then we draw the centroid of ABC, so that's where the medians intersect. We'll draw it like this. Oh, I'm going to have to relabel E and F because we used it later. Let me call it M and N. That's M. This is N. Whoops. And DG. Okay, so we draw DG and we let it intersect AB and AC at E and F. And we want to show that, okay, we draw line AG and it meets the circle at point H. And I'll also draw this point here, which is the midpoint of BC, and we want to show that angle EHG is equal to angle GHF. All right, so I'm going to hide some of the extra stuff. All right, there we go. So that's it. So we want to show angle EHG equals angle GHF. This kind of looks a little like Pascal's theorem, I feel like. Let's just check it out. So angle EHG is 25.8. They're both 25.8, it looks like. Yeah. I wonder if we want to extend HE and HF to meet the circumcircle. Hey, Hamtaro Gamer. Good to meet you. What country are you from?
I'm from Thailand.
Oh, Thailand. All right. I think that's what you said. Correct me if I'm wrong.
Yes, you're correct.
All right. So let's see. How do we do this? So we could try to use the angle bisector theorem. This actually looks a little like a problem that the person on the Discord posted, Rodrigo. It has like the tangent, but it's actually a little different, it looks like. All right. So we know AI is an angle bisector, and we want to show basically. Let me do that. Let me just for the heck of it, draw these points. I think they might be useful. Let me try this. Is HJ tangent to that? I don't think so. No. Yeah, this is a tricky one.
Can we mark the midpoint of arc BC and then try to show that it's cyclic with something?
I could try that. So this is the midpoint of arc BC. Yeah, let me draw the circumcircle of EFH. I feel like that might help. It almost looks like it passes through B, but it can't. Whoops.
It did look tangent to the triangle ABC.
Or is what tangent?
The circumcircle of EFH did look tangent to AB and AC.
Oh, really? I think you.
No.
No, because here you can see it intersects it, but it almost looks like it. But let me draw the circumcircle of EGH. I feel like I wonder what that does. I wonder if the circumcircle of EGH is tangent to MC. No, not necessarily. Checking. That was tricky. Let me try just drawing the center of the big circle. Are J, M, and K collinear? No. No, because then by the symmetry, J, N, and K would have to be collinear. Can we use the angle bisector theorem? So here John has an idea. Maybe we could use projective geometry. So like, what if we draw the perpendicular to AH? That would like form a harmonic bundle. That would form a harmonic bundle. And like we could try to. Okay, so let's see Irajan's idea. Define X as the intersection of the AC median with ABC. So XP is tangent. Okay. All right, let me see. Okay, so basically we want to reflect. I'll do it like this. So I'm going to try to draw this to median. So here's one way to draw it. So if I draw, so AL is the angle bisector. So if I reflect AH over the angle bisector, I would get this median. So actually, I'm going to cheat a little bit here. I'm just going to go like this. So P is the symmedian. And DP is then tangent to the circle. Okay. So, all right. So AP is the symmedian, and DP is tangent to the circle. It's interesting. Now we have. So BIC infinity is a harmonic bundle, right? So BIC and the point of infinity are in harmonic conjugation. So if we project through H, or we could project through A onto the line BF. So that means that EGF, yeah, what if we draw this parallel through A to BC? and we see where it meets the line VF. Yeah, I feel like this seems like it might be a good approach. So, yeah, I'm trying to make the diagram so it intersects it at a closer point that we can see.
We can delete O here and try to prove that that point XH is perpendicular to AH.
Okay.
And combining that with the harmonic bundle would give, and we can project the harmonic bundle onto the line. We already know that DBIC is harmonic. And so projecting, we just need to prove that AH is perpendicular to QX.
Yeah, or like it says Q, like we need to show AH is, did you call this point X?
Yeah, we can call that anything.
Yeah. So basically we need to show AH is perpendicular to HQ. That would solve the problem, right?
Yeah.
All right. So yeah, basically we can hide a whole bunch of stuff in the figure here. We don't even need points E and F. We just, if you draw the line DG and you let it intersect at Q, yeah, we want to show AH is perpendicular to HQ. Let's see what Ram says. Let JH and HK intersect BC at X and Y. That would be interesting. Is BX? No, I think BX is bigger than IY, or at least it looks like in this diagram, this figure right here. Well, let's see. So Arajon says we can use the perpendicularity criteria to show that. What perpendicularity criteria were you thinking of? I'm going to delete O for now. So I can delete O. I don't even really need EF. Really, I can hide a lot of the figure. I don't need. So really, all we need to look at for now is I'm going to delete these two. So yeah, we don't even really need point P. Okay, so Irajan, he's kind of using Pythagorean theorem to show QG squared plus AH squared is Q. Okay.
The circle intersects DQ at point, say, X, then is X the midpoint of GQ?
If Q, I'm sorry, if
No, I mean the midpoint of this point.
this point, right?
Does this bisect GQ?
No,
Oh,
almost. But yeah, I feel like this has to, I mean, all we're doing here, so I'm just gonna hide this median for now. Basically, we're just saying if we take this line, EG, and we let it intersect this parallel line at Q, then we're saying that AH is perpendicular to HQ. That feels like it has to be a way to solve the problem, right? I think that feels like a very fundamental fact. I'm not sure how to do it right now off the top of my head, but it feels like that has to be a way to do it, right? So Irijan, QA is equal to 2BI. That is a good point. So QA is twice DI.
we can extend DI to make it a parallelogram.
We can extend DI.
Yeah, we can just reflect D over I. That would make a parallelogram.
Okay. Let me do that.
It seems like HD dash Q is cyclic, and I think this should do it.
Okay, so what did you say about so ADD prime Q is a parallelogram, right?
Yeah. What's angle AD prime Q?
AD prime D.
AD prime Q.
Oh, AD prime Q. 39.2.
D prime, the reflection angle.
I'm sorry, I don't see it right now. So did you say angle AD prime Q is equal to something else?
D prime is the other point, which we just reflected here.
Okay.
Is this 90 degrees?
Is D prime AD or DAD prime 90 degrees? I'm sorry.
I mean, again, we will find some other.
Let me see. So I just checked it. Yeah, I don't think AD prime Q is 90. It's 102. But it almost looks like it. So okay, so Irijan says you could probably solve it without D prime. So Irijan, do you have an idea as to how to solve it? Let's see. QG squared plus AH squared equals QA squared plus HG squared. Okay, so AG and GH or AH and HG so let's see. That proves I'm looking at your criterion. So QA squared minus AH squared would be QH squared. and QG squared minus HG squared. Okay. So all right, I think I see how Irajan is trying to do it. So how do we get HG in that equation? So yeah, I guess I'm trying to see how we get GH in the equation that you mentioned. Oh, GH, you learned that as a lemma. That I guess I understand. I understand that formula that you mentioned, but I guess how would you solve for G8? Like, how do you calculate GH to then prove that that formula is true? I guess.
Is DH prime? No, I mean, is D prime H tangent to ABC?
Let's see. It looks like it. Yeah.
Yeah, I think that's butterfly theorem.
Because I is the midpoint, so.
Because they are tangents, they are similar angles, I guess.
Okay.
That has to. And I think proving them tangent makes it an angle change.
Okay. So if DH is tangent, and you're saying that's the butterfly theorem. Or D prime H. Let me delete this circle. Okay, so BD prime is equal to C. BD is equal to C D prime. Interesting. Let me check that. And that's by symmetry, since I is the midpoint of D prime. Oh, and so they have to have the same power with respect to the circle. And so if we can show D, let's see. So DA, we want to show DA is equal to D prime H. And then, is that obvious that DA is equal to D prime H? Maybe that's the butterfly theorem or something.
I think this is the degenerate case of butterfly theorem.
It's a degenerate case. Yeah.
Yeah, where the 2 points come so close that the line becomes a tangent.
Yeah, so like AH and AH are kind of like the same chord in a way. And so it's a degenerate case of the butterfly theorem. So okay. All right. So let HF cut, what is F? F, I kind of erased point F. Okay. But once we know D prime H is tangent, is it just an angle chase? Because then angle D
still doesn't look so easy.
It still doesn't look so easy. Let's see. So Serdar has a solution. Let HF cut this circle at J. 1 second. And let H, okay, kind of like, okay. So Serdar had a different idea for a solution.
I think we are close here because G is the center of homotheity which takes AQG to DGI. And this would take the circumcircle. G is also the center of homotheity of ABC to MIN.
ABC to MIN.
Yeah, MIN is basically the 9-point circle. And then we can try proving something cyclic because AH2 is 90, which occurs at many points in the 9-point circle.
Okay. So let me draw the 9-point circle. So
can you draw the perpendicular from D to AG?
D to AG, yeah. Whoops.
Yeah, it looks like it passes through the 9-point circle always.
It does. Okay.
Is that a well-known thing?
I'm not sure. Let's see.
We can try proving that.
So that would mean, let's try to prove that. So I'll try to draw on the orthocenter. That's the orthocenter right there. So yeah, we want to show ML.
I think I have a way to prove that DL is indeed lying on the 9-point circle.
Okay.
We can for now forget that about the 9-point circle and consider consider AR to be perpendicular to BC.
AR?
Yeah, AR perpendicular to BC.
Okay. Like that?
Yeah, we know that the point R, I, and R also lies on the 9-point circle basically.
Okay.
And this angle is 90, implies that it implies that
RLAD is cyclic.
Yeah.
So basically we have we have this circle, and then we also have a circle through M, R, I, and N. And maybe it's just like an angle chase to show that L lies on that circle.
Yeah, that's the Nickel theorem, if I remember correctly. Yeah, that's just an angle chase maybe, because we have two cyclic things.
So is it Michel's theorem?
Wait a second.
All right. So we have MRIN is cyclic.
Yeah, we can prove this by proving angle RM. Let me just write this. We can prove RMI equal to RLI.
RMI equal to RLI.
Yeah. Let me write and send in the chat.
Okay, thanks. So yeah, RLI is ADR. Yeah, that's what we are. We're considering that homophily centered at G with factor negative half. So yeah, we know DG is half of GQ, and we want to show basically that GL is half of GH. Let's see.
Is ADI isosceles?
ADI. I'm sorry, what is ADI what?
Is AR, no, I mean, is AD equal to AI?
Oh, no.
Oh.
Yeah, I mean, basically, yeah, we want to show, the homophily maps H to L. If we could prove that homophily maps H to L, that would solve the problem. We know it maps C to M if and only if Q lies on the 9-point circle. I don't think you mean Q, right? I think you mean L. Yeah. Yeah, we're trying to show L lies on the 9-point circle.
Yeah, I think I did complete the angle chase because we can find RMI as RMI equals BMI minus BMR.
Okay.
And BMI is angle A.
Yeah. All right, I think we got it. Okay.
And BMR can be found because, yeah.
All right, sounds good. So I like that idea. I'm gonna start writing it up. Let me hide a bunch of things. See if I can draw the figure a little nicer. Okay. Let me delete some of the stuff. I don't think we needed point D, right?
Yeah, I did finish the angle chairs.
All right. I'm going to write it up in just a second. So I'm just writing it up for the people watching on YouTube. So yeah, I'll explain right now why it's enough to show that angle QHA is 90 degrees. So actually I hit a bunch of stuff like points E and F, so I'm going to draw them back in. So basically, once we know QH is perpendicular to HA, we can also show that E, G, F, and Q are in harmonic conjugation. So from there, it follows that GH is an angle bisector. So I'm going to write this out. So yeah, so that's a well-known fact about harmonic conjugation. So let me hold on just a sec. I'm going to hide some of the stuff we added, and then I'm going to add it back in. Okay, so all right. So let the parallel through A to BC meet BG at Q. All right. And then I is the midpoint of BC. That means that BCI infinity is in harmonic conjugation. All right. And if we projecting through A onto line EF, we have E, F, G, Q are in harmonic conjugation. Okay, so once we know E, F, G, and Q are in harmonic conjugation, then it suffices to show that HA is perpendicular to HQ. And now we can start adding in some of the stuff that Anmol mentioned. So let L and R be the perpendicular. So yeah, I'll just let L and R be the feet of the perpendiculars from A and B as shown. Okay. So then ARD is equal to 90. So that means ALRD is cyclic. Okay. And all right. And then we can also do an angle chase here. So M, N, I, and R lie on the 9-point circle of triangle ABC. Whoops. All right. And then we want to show LIs on that, and we can do an angle chase. So we have angle, yeah, see here, we want angle R, maybe it's better like this on the, okay, so I'm trying to remember how I did this. So we want to show angle RLI is equal to angle RMI, and RMI, so we have angle RMI is BMI minus BMR. And that's angle A minus angle A minus twice angle BAR. Okay. And that's angle A minus 2 times 90 minus angle B. We want to show that's the same as RLI, right? So RLI is the same as RDA, which is, okay, so RDA.
RDA can be written as BA. Yeah, RDA can be written as angle A minus DAB.
Okay, so
angle B minus DAB by exterior angle property.
So angle RMI, that's, I'm sorry, RLI is RDA. Which is angle B minus angle DAB. And that's angle B minus angle C. Okay, so this up here is equal to angle B minus angle C. I'm guessing if you expand it out. Yeah, okay. So yeah, this simplifies angle B minus angle C. So this means RMLI is cyclic. All right, we're almost there. And oh, sorry, I gotta put this in dollar signs. So let me draw that circle. Ah. And then once we know that, let me make it so we can see point Q. Might just have to shrink the figure. It's so hard to see point Q. Oh well. Maybe point Q will just be cut off. Unless I make it like a really tiny triangle. Oh well. Okay, so RMLIN is cyclic, and so I'm trying to remember. Basically, that means angle. We want to show angle GLD is 90 degrees, right? Okay, I'm still trying to remember where we go from here. Let me look.
We can take homothety with factor -1/2, and it takes D to Q, and we'll take A to I, and maybe these are just corresponding altitudes of the triangles.
Oh yeah, so AG is 2GI, and so that means DG is 2GQ, or QG is 2DG. And that means a homothety about G takes L to I. I'm sorry, a homothety about G takes L to H. Or GH is 2LG. Because the homotherty about G takes the 9-point circle to the circle. Is that right?
Yeah, this implies that L goes to H, and which means QH has to be perpendicular to AH.
Okay, so that means okay, and once we know that, EFGQ is equal to -1. Means that angle EHG equals angle GHF. That solves it. Wow, this one was pretty tricky, but thanks everyone for contributing. So I'm going to move on to the next problem. But yeah, point Q got cut off. So yeah, hopefully the viewers won't be too mad at me for that. All right, so here's the next problem. It's a short problem. So we have a cyclic quadrilateral ABCD where BC is equal to CD. All right. So okay. We want to draw the circle with center C and tangent to the line BD. Let me do it like this. So, yeah, hopefully the next questions will be easier. Let I be the in-center of ABD. Okay. Prove that the line through I parallel to AB is tangent to that circle. It's kind of interesting. So, is it tangent on the circle itself? Sure looks like it, right? I think so. So basically, let's see, is that actually, I don't think that's actually true though. No, it's not tangent on the circle itself. Maybe I could draw it differently so it doesn't look like that. All right, let's check out the chat. All right, see you later, Ear John. Sorry we started off with like a super hard problem, but yeah, thanks for participating. All right, so, all right. Okay, yeah, so basically we can just say we start with the triangle ABD and we let C be the midpoint of the arc. So yeah, AI and C are collinear, right? So if we let the point of tangency be F, let's say, we want to show angle CIF is equal to angle CAB. So yeah, we could draw the tangents from I to the circle. I mean, basically we want to show IFCD as cyclic, right? So, no, I'm sorry, I don't know what I was thinking with that. Let's see. I mean, and obviously the same thing has to be true on the other side, right? So if we draw the parallel through I to AB, that also has to be tangent. So it's kind of like if we draw this point right here, G, and we draw this point, sorry. It's so hard to draw the right point. All right, I'm gonna have to do this. There we go. That's the right point. We want to show that's the X circle of IHG.
I think we can use the facts that CI equals CB equals CD, and instead of trying to prove that is the tangent, we can drop the perpendicular from C onto IF.
Okay, so drop the perpendicular from C to IF.
And remove that circle. And since we know BC equals IC and angle CBE equals angle CBE equals, it should be equal to CIF.
Okay, so
Yeah, because that would imply, because both of them are actually similar triangles. Both have
okay,
a 90 and a half of angle IBC.
okay. So I start by basically, do I start by defining F to be like do I draw this parallel line and then I draw the perpendicular from C to the F?
Yeah,
Okay.
yeah, draw the perpendicular.
And then I want to show
And
CF is equal to CE basically, right?
yeah, for that we can angle chase down CIF. We know that's A by 2. And we also know that CBE is A by 2.
Okay. So we want to show
And since,
CBE is similar to CFI.
and that's actually,
That's obvious, yeah.
yeah, that's obvious because BC is also equal to CI by in center X center.
Okay, so they're similar. Okay, so yeah, that solves it. All right, so I'm going to write it up. All right. Okay, so I'm going to call this, yeah, I could just leave it as F. I can delete a bunch of stuff too. Okay. So draw the parallel through I to AB. Let F be the perpendicular from C. I'll call this line L. And then let F be the perpendicular from C to L. Okay. And let E be the midpoint of BD. Okay. And then angle CIF is equal to angle CAB. So we have angle CIF is equal to angle CAB is equal to angle CBB is equal to angle CBB. And angle CIF is equal to angle CEB is equal to 90. So that means those two triangles are similar. And then by the in-center X-center lemma, CI is equal to CB. Okay. And so, oops. So that means CIF is congruent to CED. And then so then CF is equal to CE. And so And then if we define G in a similar way to F, then CG is equal to CE. So I'm just going to draw that point G. So if we define G similar to F, then CG equals CE by the same argument. And so that means there's a circle centered at C passing through F, E, and G, which is tangent I'll just say this circle is omega. I guess, I mean, that pretty much solves the problem because the line through I parallel to AB is tangent to this circle. All right, I'm going to move on to the next problem, but not before I draw that circle. All right, thanks for the solution, Animal. So next problem, we have a triangle ABC. L is a line parallel to BC, but we have to draw the circumcircle of ABC. So let's see. So we draw a parallel line. Whoops. F, D, E, and G. Okay, so this is F. F, D, E, and G. The circumcircles of FEB and BGC. Intersect at points P and Q, and we want to show that A, P, and Q are collinear. Okay, so draw it like this. So A lies on the radical axis of them. Oh, whoops, I called it B instead of P. What's wrong with this? There we go. Okay, we want to show A, P, and Q are collinear. So we want to show A has the same power with respect to those circles. Let's see, what happens if I move F? It's kind of interesting. So I wonder if I can use Casey's theorem here. That might be a little hard, actually. 1 second, guys. I'll be right back. All right, thanks for waiting.
I think we should mark those points where the two circles cut the segments AB and AC.
Okay, so these 2 points right here.
There are actually 4 because BFE also cuts AC somewhere. BFE.
Oh,
Yeah, one this and the other one, yeah, this one.
all right.
And something here is concyclic. HID is HIJK is concyclic, I guess. Something above is concyclic.
Kind of like we want to use the radical axis theorem, I guess, right?
Yeah, that would this here we would like to prove that AH times AD equals AI times AE. Yeah, this would mean that HIDE has to be cyclic.
HIDE.
Yeah. And I think this should be an angle chase because BFE equals
BHE.
BHE and
Yeah, okay. I think I got it. All right. So that was a quick one. All right, so let me draw the diagram so that the points are a little farther apart. Kind of like that. Okay, so Akon hopped on. Hey, Akon. Thanks for joining. All right, so we want to show A, P, and Q are collinear. So let the circumcircle. Yeah, I don't think we need points J and K, right? Just HIDE. So
I think we would need them when proving something.
Oh, I was thinking of just like using the converse of the. Okay, I'll just add them in for now. So let. Okay. Let AB meet the circles FEB and so we want FEB and DGC at H and J. All right. And then similarly, we want to let AC meet those two circles. Whoops. We want to let AC meet them at K. Oh, did I get rid of I and K? Okay, so AC meets FEB at K and I think. All right. And then angle DHE is equal to angle BHE, which is equal to angle FHE, which is equal to angle BFE. Which is equal to angle BFG. Which is half of arc BCG. And then similarly, angle DIE is half of arc FBC, which is half of arc BCG, which is angle DHE. And so that means DIEH is cyclic.
How did we get DIE equals arc half arc FBC?
Oh, this one? Oh, I'm saying we would use the same argument. So.
Oh, yeah.
All right, then. Okay, and so then that means that DHIE is quick. Oops. Sorry. And then from there, is it just power of a point? So
Yeah, AH times AD equals AI times AE. And then we can use the parallel line to eliminate AD over AE.
Okay, so we have AH times AD is equal to AI times AE. And the parallel lines, we could say AD times AB. So
yeah, we can just replace AD by AE with AB by AC. That makes A lie on the radical axis and we are done.
Okay. And so A has the same power with respect to those two circles. So FEB and BGC. So A, P, and Q are collinear. All right. Sounds good. Thanks again. And we'll move on to the next problem.